Hello everyone, for this tutorial video I'd like to discuss diffusion, which similar to surface tension is the study of fluids in motion on the microscopic or molecular level, so fluids will still diffuse even if they don't look like they're moving to the naked eye. You may have heard before that the word diffuse means to spread out in some contexts, and this is still true in the study of physics and chemistry. In particular, in any substance, even if it is solid, the atoms and molecules that make it up are always in constant motion, and so they spread out in that sense. Generally, diffusion only works at microscopic distances, because on the large-scale level, i.e. the level that we are all naturally used to seeing, the density of a material would dictate that there are more molecules in the substance, owing to the definition of what density is. And so this means that the molecules have a greater chance by sheer statistics of colliding with one another, and it is also highly likely the direction will send it straight back, so the net result is that it does not spread out. Another thing to notice is that diffusion is greater if the temperature is greater, because by the physical definition of temperature, the molecules will move at a faster rate, even though they will still move in random directions like before. As you may be already able to guess, objects will want to diffuse from higher concentrations to lower concentrations, owing to the simple fact that there are more randomly moving molecules in the higher concentration region, so they would be logically more likely to spread out, owing to the simple fact there are a greater number of molecules that exist. This can be seen in real life when you drop food coloring into colorless water, or when water is absorbed by a towel. As in the first example, the greater concentration within the one drop is much greater than the wider volume of the water, so it will want to spread out for that reason. In the towel example, it may be a little more hard to understand at first, but you should see that the water drops have a high concentration just like the food coloring drops, and you would have to look very closely at the towel to see that. The fibers that make it up have a greater surface area than the water droplets that it absorbs. And we know physically that molecules spread over a wider area would have to be less concentrated by definition. Therefore, the water will want to get absorbed by the towel, owing to the simple process of diffusion. I have now completely taught every aspect of solid mechanics as well as fluid mechanics, so this will be the final real-life physics tutorial with regards to 2D game design. But when I begin teaching 3D game design later on, I can also use real-life optical physics as a demonstration tool or analogy for how to accurately program realistic lighting into your games. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.